Let's move now to another facet of this, and that is how does Pay 360 use over-the-air updates and real-world vehicle data to improve manufacturing processes? Let's unpack that a little bit.
Yeah, okay. Well, over-the-air update is an interesting one, and it fits very nicely with the discussion so far. So, as I mentioned earlier, you've got this iterative golden digital twin that has your requirements declaratively, it has the functionality, and has software loads execution-wise, and they're all coming together. And then the question is, if I do an over-the-air update of this piece of software, do I still meet all of my requirements? It's easy enough to determine that now because you run this cadre of scenarios that are developed by your scenario team. Okay, and the scenarios are the level of, like I suggested, driving on the Autobahn, you're driving 100 miles an hour, etc. Okay, weather conditions, all that. You could also include wear on the tires or brake caliper, your brake pad wear. Okay, so you might not stop as quick because your brake pads are getting thin. There could be any number of things there, including whether or not the electronics are still functioning at the same level that they were functioning when the vehicle rolled off the assembly line. A lot of people don't understand how electromechanical units degrade in performance over time. So these scenarios can account for all of that. So when you do the over-the-air update, you may find that in a particular configuration for a vehicle, we still pass the tests. In others, we do not. But what are they? So you could actually put a warning out that says, okay, before you get this update, you need to take it back in to the dealership and have your brake pads upgraded, or you need to pull out this printed circuit board and put in a new one that has all the new features before you can upload this. So keeping track of the configurations, versions of all the software, all of those things that happen in real life in the fleet is a big part of the OEMs trying to get to the point where if we have that knowledge and we can create the digital twins that represent that configuration, then I can verify over their update before it goes out the door, and we have fewer incidences because of it.
Okay. There's one area that is also very thematic for me as I explore this topic, and that is about co-design and the enablement that you bring with something like Pay 360. So, in what ways does Pay 360 accelerate co-design between, mechanical or mechatronic systems and the embedded software for teams?
Yeah, it depends on where you start. Okay, let's say, and we've done this for a German OEM. They basically came to us and they said, blank sheet of paper. You are not allowed to talk to any of our suppliers, but use Pay 360 to tell us what our next generation automotive platform should look like.
Ooh.
So what we did is, it was a cool exercise, right? What we did is we went in and said, okay, we're going to use our tools, and then we're going to have our best architects, three of them, choose to architect that platform. Each of them came up with a different architecture. But with Pay 360, we could say, okay, let's put your architectures to the test. We ran real software on them, and we determined there were severe problems with two of them. So we threw them out. We took the one that said, okay, there's a possibility here, and took a closer look at it and said, if we modified that a little bit in this way and a little bit in that way, it looks very promising. And that's what we did. So we went off and implemented that. We implemented a higher fidelity digital twin and say, let's put heavy workloads on it. We're going to test the corner cases. In the meantime, the hardware team was off designing the hardware that was specified through that initial exploration exercise. Hardware team came back and said, you know what? The specification you gave us isn't practical because of this problem or that. Then the response was, well, what is practical? And let us go back and find out, do we still meet the requirements? So that co-design is absolutely essential. It could be something as simple as, you know what, we've got a vibration problem or we have a thermal problem based on the specifications. We're going to have to make this change, which means that software can't do this anymore. So the software team could find another way around it and do it. And yet, come back together with the digital twin, and the models from the hardware following as the hardware modifications happen, and we still got to the same end. We actually had a vehicle driving downtown Austin, Texas in 18 months. That OEM said, our team couldn't do that in 7 years. Since then, I think we're on our 6th contract with that OEM. So that was some early proof that this works at the system level and the complexity that's required. And it's actually, fed back into our product. And, we learned a lot, and it's made Pay 360 even more mature through several engagements like that with OEMs around the world.
All right. So, and to piggyback on that, let's talk about scalability as well. So for OEMs shifting to software-defined vehicle production, how scalable is Pave 360 then in supporting, hybrid hardware, software workflows? Does it unify design and simulation? Tell me more.
Yeah, that's a big question. But Pay 360 was designed with 2 primary tenets. Number one, we need to use an open AI everywhere possible, because there are tools you're going to want to plug in, and we can't do everything for everyone, and we didn't want to disrupt any existing workflows, so we keep open APIs pretty much everywhere, which is pretty unique in the market because the open AIs are extra complex and difficult, but that allows us to work with a large number of partners who provide bits and pieces of Pay 360 to do very special things. And we could talk about those partners later if you like. The other tenet was that it needed to be scalable. So Pay 360 itself primarily was built to run in the cloud. So we support all of the major cloud platforms. We've got announcements with AWS, all the others you can imagine. We have others from Asia that are knocking on our door, and make sure that we support them as well for our customers in China, Korea, Japan, who like to use their own platforms. But what we've discovered is that as this software-defined technology is adopted, an interesting phenomenon happens. It starts off with a very small team that says, look at what I can do. I can use one digital twin during a day, and I can write my code and do my debugging and do those sorts of things. But I still want to run my unit level test regressions at night. So I maybe need 3 at night. And then when you start putting multiple systems together into your golden digital twin once a month, then you might be running hundreds of instances of that digital twin in parallel simultaneously. And then when the company says, well, actually, our hosting costs are very expensive, we need to scale back, the answer is, we need more, not less. So you can see the cloud platform companies see this trend happening, and that's why they're working very closely with us to try to capture that. I did a presentation at ARM's partner meeting in August in Cambridge, England, and was questioned what was the biggest impediment, and it's the cost of cloud platform hosting. And AWS was sitting there in the cloud, and I pointed them out, and I said, you need to talk to those guys because they're charging you as though you're doing HPC computing. In reality, you're running a digital twin for automotive, and there really needs to be a different model. So the secondary thing that we've done is we said, not everybody is going to want to do that in the cloud. Some companies have their own compute centers. Now, I want to be very clear. To run these real-time digital twins, to do all the simulation, you're not doing that on a laptop. You're not doing it on a big x86-based server. It takes a rack of servers that are dedicated. They're very specifically designed, some of which we help the server create them for this specific purpose, and putting those together. So we have what we call on-premises deployment, where we can specify all of the equipment, we can deploy it inside your firewall and do all those things, but that's not as scalable, right? If you want to scale, then you need to add more capital expenditure as opposed to the cloud. And it just depends. So military and aerospace, for example, they would prefer to have it on-prem because they can afford it. Automotive companies have a choice.